All right, so back to day 5, part 2. The first thing we're going to talk about is construction lines. Construction lines are lines that are not translated into the actual object itself when you start extruding those kind of things, but it's more like a reference point for things. So, for example, if I want to find the center of something, or make sure that two things are aligned properly, or whatever it happens to be, I can use construction lines. You can turn any line that's currently existing into a construction line by clicking on it. By clicking on it and then hitting construction line, and you'll notice that's dashed. So if I were to extrude this, then I would get this shape here. I would not get this. So this would not be included in the extrude. So in that case, I'm going to get rid of the construction concept of that. But you can make a number of different construction lines. So in this case, we want to find the midpoint of this square, and we're going to draw a construction line down the middle of it. So we're going to hit construction line first, and then we're going to hit line. You'll notice you can select both of them at the same time. And I'm going to mouse over this until I see that icon. That's the midpoint icon. So again, constraints, right? So see that this says midpoint? I am constraining this construction line to the midpoint. Now I'm going to draw. And it's got auto inference down to be perpendicular, and then I'm going to find the other midpoint. And click, and there's my line. Hit escape to get out of that. And I'm going to now draw a rectangle. That's a center point rectangle, and I'm going to have it find the midpoint of that. So if I go here, I'm going to choose center point rectangle, and I'm going to mouse till I find the midpoint. There's the midpoint. I'm going to click and draw it. There's my rectangle. Now you notice I have some dimensions I can go and fill in later, but what I want to show you is that if we look at the constraints, this is in the midpoint of not only this line, but this line and this line. So it will always be kind of locked into place there. Notice that I get these horizontal constraints as well, because now this is horizontal to that, and this is horizontal to that. I have some perpendiculars as well between these lines here. So there's a lot of constraints that are created that help me kind of lock that thing into place. What you will notice is that if I grab this and try it, if I go in and I try to grab this corner and twist it, it won't let me. It won't rotate. It just gets skinny. So I can grab it here. I can still adjust it along that axis, but I cannot rotate it. However, if I show my constraints and I get rid of this horizontal here and here, then I should be able to then rotate it like so. So you can see the importance of a constraint, that if it's not done properly, this object could be spinning around inside of this three-dimensional object, and we would not have the correct design intent that we want. So I'm going to hit undo there a couple times and get back my constraints. So this one is going to be horizontal. That one is going to be horizontal as well. Now, you'll notice it's still not fully constrained because, again, I haven't dimensioned this yet. So what I'm going to do now is I'm actually not going to dimension the size of this arm. I can do relative dimensioning based on the position relationship between one side here and a side here. So I'm going to click here and click here, and then I'm going to hit D for dimension. Sorry, here and here. And you'll notice that when I had dimensioning on, when I first clicked here, it said, okay, well, you want to dimension that because it's the first thing I clicked on. That's okay, but as soon as I click on this line, you'll notice that now the orientation changes, and I'm dimensioning the gap in between them, which I'm going to set at 0.5. So you'll now notice that these sides are fully constrained because, again, they're perpendicular, they're parallel. All the different constraints that we have going on here have forced them into the same dimension by simply constraining one component of it. I can do the same for the top as well. So if I wanted to say that this and this, this and this were also 0.5, I could do that. Now, what might be better than even dimensioning that? Well, I could say, instead of doing that, I could say this, 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 and this are all equal. Now it's fully constrained. That's one less dimension. So if you find yourself getting cluttered diagrams, it's probably because you're not using constraints as much as you should, and you're using dimensions more to force things. But if you think about what does this thing logically have to be or do, then a lot of times you can constrain things down to where you only need a few dimensions to really lock things into place. So that's all well and good, but what happens if you start using too many constraints? What you can do is you can get what are called over constrained sketches, and what that basically looks like is, let's say I choose this, and I try to do parallel. It's not going to work, and even if I tried, I'm sorry, not equals, parallel. If I try to do that, you'll see I get all these red lines all over the place. What that means is that constraint I just added conflicts with other constraints that are already existing. So if I try to do that, it's not going to work. This will not extrude. It will not work properly. So I'm going to hit Control Z. Now it's all gone away. Now it's well and good. So if you see red, that's bad. That means you have constraints that are conflicting with each other. Obviously, these can't be parallel if they're also perpendicular. They can't be both. So that's why you get that red there. So that's the basic gist of doing some dimensioning and construction lines and over constraining. I'm going to leave you to the clock activity on your own. It's pretty straightforward. You should find the file in there, and basically you can just see that if you play around with the clock hand, that because it's anchored in that center point, doesn't matter how long the clock hand is, everything else will stay the same. The one thing that I will mention is that you can go up here and do workspace units. And you can choose what type of unit you're going to be working with. And we're going to be working in inches primarily in this class. I know metric is more precise, but we're going to use inches for this class primarily because when we convert it to files for 3D printing and those kind of things, it just makes things a little bit easier for us. So inches will be the default unit here, but you could change if you wanted to foot, meters, millimeters, yards, whatever you want to do, depending on the size of the object that you're building. Most of the things we're going to be building are smaller, so we're going to work in inches. So that's it for day 5. Make sure you play around with the clock, and then we will catch back up with you on day 6.